Okay, guys, part B. Use the second derivative to determine whether your answer in part A is an underestimate or an overestimate of the initial temperature of the potato at time t equals 3. Okay, so there's a lot there, but what I know right off the bat is I need the second derivative. I need dh dt, uh, d2h over dt squared. So here's the function. It's a pretty straightforward derivative, okay? So if I take the derivative, I'm going to get, essentially, I could write dh over dt equals negative 1/4 h plus 27 over 4. So when I take the derivative, this is a constant. It's just going to disappear. So if I take the derivative of that, I get negative 1/4 dh over dt. Oh, rats. Got dh over dt in. Oh, that's okay. I know what dh over dt is. It's right here. So that equals negative 1/4 times dh dt. I'll use this expression here. Negative 1/4 h minus 27. So that equals 1/16 h minus 27. That equals the second derivative. Okay, cool. All right. So now what are they asking me? They want to know, does it provide an underestimate or an overestimate? Okay. So guys, if a curve is concave up, if the curve is concave up, a tangent line is always going to be shoot low. It's always going to be providing an underestimate. If I'm concave, so that's concave up. Concave up equals an underestimate. Okay. If I'm concave down, the tangent line approximation is always going to be shooting high. So concave down equals an overestimate. Okay, you can draw this little figure on your solution. Okay, so I got to find the concave up and concave down. So the second derivative of h with respect to time at time t equals 3, and I think we want to use. Oh gosh, that's right. Here, this is where this 27 degrees. It's always above 27 degrees. The temperature never falls below 27 degrees. So the second derivative is 1/16 h minus 27. H is never going to fall below 27 degrees. This is always going to be positive. So second derivative of h with respect to time is always positive, greater than 0. Therefore, concave up. Therefore, it will be an underestimate. Okay? That's part B. Sadly, 1 point. Okay? 1 point to find the second derivative. 1 point to realize that you're finding how to use this nugget of information back here that h is always greater than 27 degrees. So that it was always going to be concave up, and concave up always provides an underestimate. So, or guys, you probably, I'm not sure why, but you probably could have used the estimate from before, 3 degrees, well, 43 degrees. They want to know whether that's an underestimate or not, so you couldn't use that. You had to use that nugget of information. That was kind of a hard part of the problem. It was a little bit of a stretch, but it was only worth 1 point. So the last part of the problem, which looks kind of ugly, part C, okay? So, um, so what do they got here? For t greater less than 0, an alternate model for the internal temperature of the potato at time t minutes is the function g that satisfies this differential equation. So h is out the window, guys. All the stuff up above is gone. All right, there's a new function in town. G of t is measured in degrees Celsius. Same initial temperature. When time equals 0, the initial temperature is 91. Find an expression for g of t. So what that means, you should know from the separation stuff we talked about earlier, I got to integrate this equation. Okay, I got to integrate this equation. It's dg over dt, and there's g over here. So I got to separate variables again. That's what I'm going to do. And then they want you to use it to estimate the time and the temperature of t equals 3. I'm going to do separation of variables. Okay, So I've got dg, and guys, this is worth 5 points. dg over dt equals negative g, that looks like 6, doesn't it? G minus 27 to the 2/3. Okay? So I'm going to separate variables. Okay? There's nothing but g here, so it's going to go to the other side. I'm going to get dg over g minus 27 to the 2/3 equals negative dt. Okay? I'm going to do a little u substitution. U equals g minus 27. So du equals dg. You don't really have to do this. You probably do it in your head, but this is safer. So I get du over u to the 2/3, which equals du. I like u first. U to the negative 2/3 du equals negative dt. Okay, now I can integrate. All right, if I integrate, I get u to the 1/3, add 1, divide by the new power, divide by a third, that's equal to multiplying by 3, equals negative t plus c. Okay, and I'm looking over, that gets you 2 points so far. It was 1 point to do this, it was 1 point to get to this. Now let's solve for the initial condition. Hang on guys, let me put g back in. 3 times g minus 27 to the 1/3 equals negative t plus c. And now I know g of 0 equals 91. So I can plug in 3 times 91 minus 27 to the 1/3 equals 0 plus c. 91 minus 27. I know you guys won't have a calculator, so you could quickly do that. It's 64. I raise that to the 1. You should recognize that 64 to 1/3 power is 4. So 3 times 4 equals 12, which equals c. Okay, so c equals 12. That is another point. Okay, so now what do we got? We've got 3 times g minus 27 to the 1/3 equals negative t plus 12. Okay, they want g by itself. So g minus 27 to the 1/3 equals negative t plus 12 over 3. Okay, so then I get what? I get g of t equals 27 plus 12 minus t over 3 to the 3rd power. Okay, so that's it. All I did was I cubed the right, 12 minus t over 3 cubed, and I added the 27. That's to save paper. I'm going to do the last part. So that, guys, that gets us up to 4 out of the 5 points. They want g of 3. So g of 3 equals 27 plus 12 minus 3 over 3 to the 3rd power. G of 3 equals 27. Let's see, 12 minus 3 is 9, divided by 3 is 3, plus 3 cubed. Okay, so that's 27 plus 27. So G of 3 equals 54 degrees Celsius. All right, that's the problem, guys. Separation of variables, they love it. 5 points. So I'll upload this with the solution as well.